Okay, question number 11, we're going to solve this quadratic inequality, and we're going to find out where it is greater than or equal to 0. Again, you could do it any one of several ways. You could factor this one. It will factor. You could use your completing the square. It will work. And you could also use your quadratic formula. For me, if I have the option and it's available for me to use, I'm going to factor. So I'm going to demonstrate factoring. So when I factor it, I want to make sure my leading coefficient that's in front of there is positive. So I'm just going to write it negative x squared minus 6x minus 5 is greater than or equal to 0. If this is not equal to a positive, I always make it a positive by factoring out a negative. So it's x squared plus 6x plus 5. And I'm going to take it out of all of them because my idea is I'm going to factor it. Because I'm pretty sure I can think of factors of 5 that'll add up to 6. So I got a negative. Trinomials, if factorable, factor into two binomials. X, x, the signs are the same. They're both positive. Factors of 5 are 5 and 1. And that gives me a 5x on the outermost, a 1x on the innermost, and that gives me a positive 6x. So I know I've got it factored correctly. That means, and again, I'm going to really think of this to start off with as just equaling 0. What inputs can I put in for x in these two locations to get 0? Well, this one is x would have to be a negative 1. The second one is x would have to equal a negative 5. Now, these are the anchor points on my number line that I'm going to do. I only need an x-axis number line to figure these out. This is a negative 5. This is a negative 1. Now, these are important because this is where we have exactly an output of 0. So I know my outputs are 0 here and here. I'm going to come back and look at my original graph or my original equation, and it said it's a negative x squared. That is a clue or a key, whether I look at it here or I look at it here, is telling me that the graph is frowning. So what I have is a quadratic equation or a graph or parabola that opens downward. Now, I know that these were my anchor points that said it's equal to 0. Now I know anywhere that it's above means greater than 0. And if it's below, which is out here, it is less than 0, or below is interpreted as below 0 is less than 0, pardon me. So below over here is less than 0. I'm going to go back and check out the inequality symbol. The inequality symbol said we wanted them when they were greater than 0. So the x values that give me outputs that are greater than 0 are situated in between and including because it can be equal to 0, my anchor points. So this is the graph of my solution set. Now the interval notation that you're asked to write, well, that is every number from a negative 5 included all the way up to a negative 1 included. This is your interval notation. I'm done. Remember, if you didn't like factoring, completing a squared quadratic formula should give you these exact same anchor points. You're still going to have a graph that's going to frown. You'll still find the same values in between. So you have the liberty to pick which method you want on those.